kick off. Great.
We're recording. Okay. And my dog is getting ready to bark. I'll just let you all know that. So, but welcome everybody to the Emerging Centers call of the CARC People Network, the Emerging Centers facing CARC People Network. Today we're kind of excited that we have these new XSEDE resources. The leaders of these new resources that are going to be coming online, they'll talk to you about those and talk to you a little bit about what services they're going to be providing, and hopefully a little bit about who you can kind of send to those services, what use cases will work best with those. So we'll have Carol from, we're going to do Anvil first, she's from Purdue University. Thank you, Carol. And then we have Dave Hancock from, Bridges. We have Shawn Brown from Bridges from PSC. And then we have Dave Hancock from Jetstream2. So what we'll do is they'll each speak for give a little bit of talk for about 10 minutes. We'll have about 5 minutes for questions and answers specifically about that individual resource. And then in the end, if we have any time, we can kind of talk amongst ourselves and ask questions about any of them. So you guys okay? I guess we'll kind of wait until after the 10 minutes if you have a presentation. So Richard just put into the chat, please sign into the call document and put your information like we always do. And I don't think there's any other details we need to have. Do you think of anything, Rich?
I think that's it. Just, yeah, please be sure to join the call doc and sign in, and we'll be counting heads and making sure that we've got everybody on.
And if you think of any questions while they're speaking, if you want to put them into the chat, then we can, Rich and I can actually bring them up after they're done, or if there's something.
Rich, I don't think that one's publicly editable yet.
It's always a problem. Okay, so I think we can go ahead and move on. So Carol, if you wanted to get started, I've made all three of you co-hosts, so you should be able to share your screen when she's done, but we can transition as we needed. Thanks.
Okay, I assume you can see my screen. Okay.
Yes.
All right. Thanks, everybody. Thanks to Rich and everybody on the CARC team for inviting me to talk about our new resource. Obviously, we're very excited for this new Anvil resource that we see as a platform forging for the future of computing. Given the time, I'm going to be talking really fast, but it should be pretty informal, and I'll be definitely happy to answer questions at the end. So Anvil was in response to the NSF solicitation in 2019 for the capacity system. Addressing some of the urgent needs in the national computational landscape, we proposed a system that's funded now by NSF. We call it a National Composable Advanced Computational Resource for the Future of Science and Engineering. It'll be deployed and operated by a Purdue team. Our Research Computing Center, many of you probably are familiar with some of the people on our team, Preston Smith and others. So the plan is to deploy the machine to be operational on October 1st, 2021. We have a team of investigators. I'm the PI. We have a couple of people as co-PIs, and both Rajesh and Shao are on this call to answer questions. Okay, so a little bit about the award. The system would be $10 million for acquisition and additional funding for operations for 5 years. And it'll be allocated just like any other XSEDE resources. And we'll start allocation for the fourth quarter of this year. And we do have an early user program that we plan to start in August. I'll touch on that a little bit more later. And so essentially, we designed Anvil to meet the three major needs. One is the continuous increase in demand for computational resources. As many of us are aware, XSEDE allocations you put in are very often get cut. The second one is really to bridging to the future to support the expanding and evolving applications, such as the new computational paradigms that have come around in recent years. And the third goal was really to have a significant program to develop the next generation workforce. And specifically, we focus on the CI facilitation professional workforce, sort of like what a lot of people in this group are doing. So as far as, what we put into Anvil, it has system-wise, it has mostly two big components. One is the major compute cluster, a big one with GPUs and large memory nodes. And also we have a composable subsystems, which I'll get into a little bit more later. And obviously, the software ecosystem is very important, and also a major training program. Let's see, diving a little bit about the systems resources. So you can see that we have a really big, sort of a traditional high performance computing cluster with the latest AMD processor, codenamed Milan. And also we have a subsystem of GPUs with A100 and 32 large memory nodes with 1 terabyte of RAM. And similar to other XSEDE systems, we have a multi-tier storage system with project space and a large scratch space for every user. And we also support Globus. I'll get into the composable system later. And so talking about some of the application examples, some of these are pretty natural for the HPC systems and the GPU nodes that are going to be in Anvil. We're putting in a few examples here. I'm sure the researchers that you're working with have similar needs. And whether it's to solve protein structures or having these big data applications for genomics data. And other examples are from our astronomy department to use AI-based methods to track observations and analyze the data from the observational data. And we have on our campus, we have a big and very strong aeronautics program, and they use a lot of the CPU compute for CFDs and things like that. As for the newer type of applications, we have people from the College of Liberal Arts to use remote sensing data to track and model in their study of archaeology problems. So I want to switch gear a little bit about the new computing paradigms that Anvil is designed to support. So first of all, we have a big emphasis on interactive computing. So we have nodes allocated to support these open on demand and thin link users. So basically, you would use these graphical user interfaces or environments you're familiar with, like Jupyter or RStudio, to access the nodes on the cluster. And there are a large number of applications we're going to support. obviously, we're still learning from the other providers about, handling licensing and talking with our vendors, but those things will be on our website eventually. Okay, and for the composable systems, so this is new in the sense that we're operating it together with the large compute cluster. And so that opens a lot of doors for scientists to not only do their computational intensive work using the GPUs and CPUs, but also do a bunch of other things that typically or traditionally not done in the same kind of place, right? So for making their code available as interactive applications, for portability, reproducibility, and all those good things. So essentially, the idea is the research groups with help, or maybe some of them can do it themselves, can create Docker images, containers, and upload them to registries in these open source places. And they can deploy them through our Kubernetes managed cluster, composable system, and run their applications there. And then to look at the data results and in order to either improve their methods or maybe deploy these things further for sharing with other people. So some of these applications examples are, science gateways, or even not full-blown science gateways, but just applications that's all packaged up, so their users don't have to deal with dependencies and so on. So those are some examples that could help people to think of potential usage. Just a quick statement on how it's going to be allocated. And many of you probably are familiar with the startup allocations that you can request anytime, and the formal research allocations. We're going to be ready for allocation for the October, for the fourth quarter of the year. So you probably need to start thinking about it in June and July. And we're going to be able to support people, since this system has a new processor, and you probably don't have access to do any benchmarking yet. So we'll work with you to on getting your allocation, the scale factors, and all those things figured out. A lot of these information will be on our website, so I won't go into the details. But to say that in this grant, we did budget for not only the help desk support, but also some advanced user support. So like I said, from the allocation stage all the way to actually using the system, we'll have people and domain experts as well to work with users. So we do have an early user program. Rajesh and Shao, they're leading that program. So if you have any questions, feel free to put the questions in chat. They'll be able to pick them up. And so we're targeting for a start in August. Right now, obviously, we're still waiting for components to arrive on campus and actually be able to go in and put the system together. So we say that's our schedule. We'll see. And we hope everything would go smoothly and we'll be able to deliver on that timeline. And so here's some resources that you can feel free to check them out, and the timeline here. And with that, I'll be happy to answer a few quick questions.
Thank you, Carol. If anybody has questions, you can ask now, or maybe as we can move forward and see the other new resources, and then I'm sure the questions are going to come up along the way here. But that's an exciting one. Does anybody want to have a question they'd like to ask? can put it in the chat. I see something in the chat. Oh, just the sign in doc. Okay, well, I think then it's a lot to take in. I think maybe we'll just go ahead and move on. And Shawn, if you'd like to share with us what Bridges-2 is going to offer us.
Sure, just a second. Are you seeing my, come on,
Yes,
slide or presenter screen?
presenter screen now.
Always have to ask.
Yeah, it's good.
Okay, there, is that better? Great, I'm not sure why there are two dots there, but okay, so I'll be introducing Bridges-2. So we're actually already in official production. We just completed our early user program and got through the NSF review, and as of March, we are actually in official production and being allocated through XSEDE. So I'll give you that link at the end. It's the same link that Carol gave. So it's that's the nice thing about XSEDE. It's all in the same place that you get this stuff. So my name's Shawn Brown. I'm the director here in the PI of Bridges-2. So this is the machine. We were awarded this by the NSF in October 2019. Various and sundry things happened during our shared, as our program officer tells us, our shared national experience. And we were able to get the machine deployed in November and conducted our early user program in January, which was very successful. We had about 250 some users, 183 projects, lots of service units, and the machine performed at 99% availability the entire early user program. So we're really excited about Bridges-2. It's deployed in collaboration with Hewlett-Packard Enterprises, and I'll tell you a little bit more about what we have to offer in the machine.
Shawn, if I could interrupt, I think we did get it flipped. The viewers are seeing your next slide right now. Now we see two slides.
That's this. Okay, let me swap it again. Is that one slide now?
For me, it's a piece of one slide.
Okay.
Right.
Let me reshare. Let me reshare it then. Sorry about that.
No, that's fine. I just wanted to help our folks see everything.
Yeah, no worries. Is that better?
There we go. Perfect. That's great.
Okay. So, so you all saw that's the big slide. There you go. That's what it looks like. We decided to make a really nice presentation in our machine room. Usually our machines are they kind of look boring. So we decided to actually put a mural on it this time, so that when you come into the PSC machine room now, this is what you see. So it's you're enveloped by Bridges-2 when you come in. So it's all around you and hugging you and making you feel good. So why did we propose Bridges-2? So Bridges-2 is mainly developed as a platform. So we are following on from what our very successful platform Bridges, which was centered around new communities and complex workflows, to Bridges-2, which is now our platform for supporting big data and rapidly evolving research. So our primary use cases are, of course, traditional HPC and simulations. We've put a very heavy component of AI and machine learning ability into this, and allowing it. One of our major use cases is people doing a lot of simulations and then doing AI and machine learning on the results of those simulations. And so we have some very scalable AI and machine learning components to Bridges-2. Open, shared, and big data services. Our landscape has gone from being computation that's heavy on using lots of cores and trying to scale up our things to run on thousands of cores, to being more capacity driven and being more data driven. And so we have a very nice data capability on here, and we're working towards openly sharing data sets and computation. User-focused productivity and interactivity, much like what Carol just presented. We also have a focus on interactive computing and making sure that we're building these platforms for the users rather than building them and then they will come. So we really want to make sure that we're providing a user-focused productivity component to this. And we'll be working on cloud interoperability and heterogeneous workflows as well. So the core concepts of Bridges-2 involve converged high-performance computing, AI, and data all in one platform. So it's a heterogeneous supercomputer that provides a number of different types of computing, very similar to what you just saw in Anvil. Large memory GPU and capacity computing with a very nice data infrastructure, all connected by a custom fat tree class topology of the HDR200 InfiniBand. So a very fast network, everything's very accessible across the whole machine. We put a very nice GPU capability on here. I'll talk about that in a second. With NVIDIA Volta 100s, 32 gigabytes, eight cards per node, all NV linked up. Different memory tiers. It's got an extremely flexible software environment, and as I said, we're working on community-driven data services. I guess if you want to, in helping our partners here at Purdue, if you would like to benchmark on AMD EPYCs, we have those. I think that's the same chip that you guys are getting. We do have a bevy of those, so if you need some help or need to do a startup allocation to prepare for Anvil, you can go ahead and benchmark on Bridges-2, and that will be the same AMD processor that will be there. We have I'll tell you a little bit about the tiered storage network in a little bit, but we have various and sundry storage capacities in a tiered network for people to use. So our driving use cases, we really want Bridges. The overarching theme for Bridges-2 is that it's a component of the computational ecosystem. It's not true anymore that you build one of these machines and that it's an all-in-one stop shop for everyone to do everything that they could ever do in their computational workflows. Now there's all sorts of ways for people to interact with computing and the environment around them, and so we want this to be sort of a component of the larger computational research ecosystem. So seamless integration with web-based applications and data analytics platforms, scalable AI, machine learning, combining large-scale simulation with AI and machine learning. This is a very big growth industry, as I see. The graduate student in the lab cannot run 10,000 or 20,000 simulations and then be expected to make an Excel spreadsheet to tell us the results at the end. We have to actually have better capabilities, and AI machine learning presents that kind of opportunity for people. Analysis needing large scale memory. We have nodes on this machine that have up to 4 terabytes of shared memory, data-centric analysis and high throughput computing. Integrating with cloud services. I recently took a position also in joint with the University of Pittsburgh, where we're working on this and providing burst capabilities and integrated cloud services with Bridges-2 at the University of Pittsburgh and their campus computing. Support for the broad and ever-changing research community. So we made it flexible so that as this is going to be a 5-year machine, we want it to be able to evolve over time to support the research community, interactive computing modalities, and then augmenting traditional computing with rapidly evolving methodologies and data analytics. So with the priority on flexibility and ease of use, we're supporting a number of different ways for people to interact with the computing platform. So interactivity, as I had in my next slide, we support open on demand. We really like open on demand. And are working to enhance it to provide as many applications as possible through that platform. It's a little bit of a pet peeve of mine that some of my colleagues say, interactive computing is about getting things instantly. Getting things instantly is about resources, not about technology. Interactive computing is possible on these machines, and it sounds like also with Anvil, and I know on Jetstream, interactive computing is Jetstream2 interactive computing is a big component. It's available on these, and you can get whatever resources you want to be able to do your Jupyter notebooks, your MATLAB, any of those things through the web interface. And so we support and provide that. You may have to wait if you want half the machine to run a Jupyter notebook, but I think that's just kind of par for the course. We support all the popular high productivity languages as well as low-level languages, have all the compilers and such. We're doing a lot of work to make sure that we provide AI frameworks and containerized and standard formats for people to be able to run their AI and machine learning quickly and easily. And we have a lot of service nodes that allow us to reconfigure the machine and reconfigure components of the machine depending on what the needs of the community are. I don't know if the chats are coming up for me. Okay, good. Okay, just want to make sure because I can see that little thing dinging for chat, and I don't know if it's for me or not. So if you have a question, you feel free to stop me and ask. So this is what we have on Bridges-2 in terms of the compute node capacity. We have what we call the regular memory nodes, which are each have 128 cores of AMD EPYC 7742, 256 gigabytes of shared memory. We have 16 of those that have 500 gigabytes of shared memory for a little bit larger memory applications. Then we have the extreme memory capability. We have 4 of these that are based on Intel Cascade Lake that have 4 terabytes of RAM for things like genomic sequencing and analysis and other data-centric and data-heavy applications. Our GPU partition has 24 nodes, each with 8 NVIDIA Volta 100 32 gigabyte GPUs are all within node. They're connected by NVLink so that they can work together within node. And then we have them connected in an extreme way in the InfiniBand Connect so that you can really run applications, AI applications and simulation applications across all the GPUs on the machine quite fast. And then we have a number of service nodes that we can reconfigure and provide data services, web application services, virtual machines, containerizations, things like that, that are flexible, that we can adapt depending on the needs of the community. Every one of the nodes has an NVMe hard drive in them, SSD drive, either 4 terabytes or 7 terabytes, which is important for the feeding the computational beast, as it were, moving data in there quickly to be able to access and not make data flow the bottleneck in our applications. This is just a high level view of the overall architecture. All the big takeaway from here is that the interconnect is throughout the whole thing. So you get a very good connection speed to all parts of Bridges-2, no matter where you are in the system. And even with the GPUs, we have GPU direct, which means that the GPUs don't have to go through the CPU to get to the network and talk to each other, which makes them even more scalable as well. Although I'm jealous of Carol because she's got the A100s. I want A100s. I love A100s. They're awesome. I'm jealous. So our data infrastructure is one of the key pieces here. We realize that, you know, in AI and machine learning, as well as other data-centric applications, the data capability of the machine is really, really important. So we invested in this HP's cluster store technology, which is coming out of their acquisition of Cray. And so we have really 3 tiers of storage as part of our big parallel file system. The first one is a flash array, which we call Jet, which has approximately 200 terabytes of usable storage. This is for very high IOP applications, so small files, lots of files. Actually, we run our home system off this, and it's been tremendously helpful in people experiencing perceived very high speeds and not a lot of delays in terms of interacting with the machine. And then we have a large spinning disk Lustre file system that's 15 petabytes of usable storage. That's called Ocean. And on top of that, Ocean also has a tape library that can do far-line archival storage. And that's about 7.2 petabytes uncompressed, and depends on how you compress it. You can get up to about 18 petabytes of storage on there. That is all going to be managed by HP's data management framework. So the Ocean, the reason I say that the tape drive and the Lustre file system will be together in Ocean is that it will be a single namespace and transparent to the user, so that we can tier that data off of there and archive it for long-term storage for data that's not readily used. But the whole goal of this is to be able to have data in the right place at the right time and be able to get the data to the compute as quickly and as efficiently as possible. So this is the team, the leadership team. I like to put pictures of the team up so you can see all their faces. One of them's on here already. Sergio is on the call with us as well. I had a great team that's helping to manage Bridges-2. in all areas of the project. And then we have a big team at the PSC backing this project. Not all of them are funded by the project, but they all are contributing in various and sundry ways. And if you want more information about the PSC, you can get more information at our website at psc.edu. If you have any questions, need anything from us, you can always email help@psc.edu, and we'll get back to you as quickly as possible. If you're on the tweets, if you like tweets, you can follow us at PSC Live. I'm not the tweets person, so you won't see me tweeting very much, but we do tweet a lot at the PSC. And if you want an allocation, currently Bridges-2 is available to the community through the XSEDE allocations. We are, I think the allocations deadline for the latest round of proposals is just completed, but will be available for the next round of proposals if you would like to get allocation on it. And that's all I have. Thanks.
Thank you, Shawn. Does anybody have any questions for Shawn and his rapid fire explanation of Bridges-2?
Is that politely saying I talk too fast?
No, not at all. You got in just in time, and you're
I had 10 minutes. So.
no. Yeah, I know it's tough. I was going to say, we wanted to give kind of an introduction here, but we may be inviting you all back for longer term, more interactive type sessions, because this is a lot of information, but I think it's good for everybody to see the kind of snippet of it. So
looks like we do have a question in chat.
Sure.
Elisa Kang asks, can you elaborate more on cloud interoperability? Sure.
Yeah, so some of the projects that we're working on, obviously the storage piece, that's a no-brainer. I mean, being able to seamlessly tier with the storage on the cloud, regardless of which cloud provider you have, is one that we really are working, that we want to have that capability. HP's DMF actually provides that capability, as well as we're looking at some other solutions to provide that. The burst computing, we're actually, one of our projects at Pitt in the Center for Computational Research that we're working to leverage will be being able to apply to being able to actually submit to the queue without you even knowing where the cloud computing is going, to be able to basically interact with that component just like you would any other component of Bridges-2, but you'd be able to bring your cloud resources to it. So what do I mean by mount cloud storage on Bridges-2? Well, I don't think, well, it depends on how you look at it. So, I mean, sharing a namespace could be considered mounting, but it's not necessarily actually mounting the file system on there. It's things like DMF and other platforms allow you to be able to interact and make it look like it is the same namespace because they can share metadata together. So it's more, I wouldn't call it mounting, it would be more like a metadata sharing type thing, to be able to seamlessly, like if I want to be able to say, I'm on a command line and I want to go right to the cloud, and being able to do that in a namespace type way, like CD to cloud. That's the kind of thing that we're integrating into this. So eventually it will be kind of, depending on how you use it, it will be, if you like CyberDuck, you can use CyberDuck. If you like doing it on the command line, you can do it on the command line, but it will be like more like a seamless integration with getting you access to your cloud resources. I hope that answered your question.
Yeah, thanks.
Yeah, sure. John Huffman has his hand up.
oh,
Yes, thank you. So I know it's both the speakers, so thanks to both of you so far, and I look forward to Dave's talk as well. But I'm seeing the trend that that you're both using the AMD EPYC systems. Of course, that means is we're getting 128 cores per node now. Is there have you seen any issues or are there any concerns about bandwidth contention? Because obviously we're now looking at systems that have 2 or 3 times more cores than we're used to seeing in traditional systems, and the network fabric hasn't really caught up to that, especially with small IO and some of the MPI jobs and other things. It seems like that could be a real issue with that many cores per node. Are you guys seeing anything like that so far?
We're seeing, I mean, we're seeing the normal stuff. I mean, it is, you're absolutely right. We are seeing memory contention issues just because you're putting 128 cores. And I mean, there's also hardware level hyper-threading on these, so you can get up to 256 hyper-threads on there. I think there's a large community. There's also another machine that's at SDSC that is Expanse, which also has the same processor in it. So we're working together as a community to optimize codes and get the appropriate optimizations going on there. But I mean, in the end, you're barred by physics. You are putting 128 cores in a node. What this really, the use case for this is really also the capacity computing. So we're seeing, I mean, if you can, the memory channels are really good in the nodes that we have. So if you're not trying to run all of 128 like a very heavy communication pattern type thing, that seems to work and scale pretty well. If you're doing quantum chemistry on it, well, I mean, let's all be honest, quantum chemistry doesn't scale on anything. So this would be, you'd see the same problems. I mean, we are putting a lot of cores with the memory on there, but these nodes have a lot more memory channels than before with the Magni core or anything else like Istanbul. So it's a lot less of a problem than before, but we do see it.
Yeah, so this is Shawn from Purdue. I want to, probably echo what Shawn mentioned. We have, in addition to Anvil, we have a system which is the community cluster at the campus level. It's a Bell, and it's on the AMD second generation. And by the way, for Anvil, we're going to have the third generation of AMD processor.
Okay, great.
And we're going to have the DDR4 3200 memories. And what Shawn mentioned is exactly what we observed on Bell. And some of the code they do probably have the issue with the memory bandwidth. And in that case, of course, some of the code like a Wolf is probably an example very sensitive to the memory bandwidth. And we have seen people moving to MPI plus OpenMP will help. And also, you can slightly reduce the number of the cores you use. But overall, as Shawn mentioned, it's a capacity system, and the cores allow people to do interesting science. And also, we allow the sharing of the nodes. So that's helps the throughput. So that's probably our experience from Purdue.
See, now I'm just getting more and more jealous of Carol every time you guys open your mouths.
Sorry, Shawn.
We'll let you run on it.
Oh, thanks. I appreciate that.
Okay, I think we'll go ahead and those are great questions. And we'll move on to Dave Hancock with Jetstream2, so we can get all three of these in here and then have more time for questions at the end. So Dave, if you're ready, go ahead.
Yep. I'm going to do this a little differently here. So just because I find it screws up less on me. Are you guys seeing PTI slide and what is the back of Jetstream there?
Yep.
All right, perfect. And let me know if my audio goes funky. It sounds like I'm in an auto tune. My Mac was giving me fits all day yesterday, so hoping it doesn't reappear.
Yeah, okay.
So I'm Dave Hancock from Indiana University, the director for advanced cyber infrastructure, responsible for our institution's centralized HPC and cloud systems, storage systems, archival systems, and also the PI for Jetstream and Jetstream2, which is what I'm here to talk to you about. And I think George Turner is on the call as well, who's in our organization and been helping with both those projects for many years too. So as a refresher, this is kind of what the current Jetstream environment looks like. It's evenly distributed between two sites at TAC and IU, more or less. There's a small internal expansion on the IU side where you can do some GPU testing and other things, but functionally it was a pilot and production environment for the NSF when we started that endeavor in 2014. And the first place I like to start is what of that worked and what didn't work. So some of the things that worked that we weren't necessarily sure about was allowing API access, meaning access to OpenStack APIs pretty much immediately, handing over root privileges to anyone and everyone. I'm a sysadmin at heart. This was frightening, but it's worked great. Indefinite workflows, being able to run jobs what are kind of jobs VMs forever, or at least for multiple years in some of these cases, providing PIs renew their allocations, and getting things out the door quickly. So trying to cut down the barriers to access, to saying, come have a trial allocation. We don't necessarily care your status. You can try out Jetstream. Here's a very small limit. See if it works for you. And if it does, great. If it doesn't, find something else. But before you're putting the time into going in for a startup or other things, which arguably is only a paragraph or something, but there's still a barrier for people. So some of the things that didn't work, forcing these smaller allocations into research allocation processes. There's can frankly be a stigma with some of the allocation processes and kind of gatekeeping at times of getting access to resources. And these startup allocations or smaller allocations aren't always treated as important or as equal as somebody who needs large computational cycles. So we've been pushing XSEDE and the XRAC committee on that for some time. Lack of multi-year allocations, institutions, researchers that come in with 3, 5 year or even more longer grants want some assurance that if they move their data and processes to a system and environment that they'll continue to get that renewed. There's been some progress there, but that's something I think we all would like to work on. And we were really limited on the amount of shared data storage in Jetstream that we're improving in Jetstream2. So, why does it exist? Well, first of all, because we think have proven that Jetstream was successful, and so, but it was also limited. It was a very homogeneous environment, and so with what was little investment in Jetstream, we made a large impact, and that's seen especially on the education side with 6 times the educational service units as any other resource, and the impact of reach of users, and especially gateways where there's over 50 science gateways on the resource, those bringing well over 60,000 users from that community on there for some of these gateways, some very small, some quite large. We also have a stress on this broad accessibility and something we call AI for everyone in Jetstream2, and the idea for that is there's not been a lot of these GPU based and AI resources in XSEDE, and that's growing. And how do we make those more widely available, especially for education? So we'll be allocating, be able to sub-provision GPUs for some of these instances and do some unique things because of our virtual environments, and do so on demand, which has been great. Some of the capabilities that are being deployed in Jetstream2, and improved orchestration, having a real look at some of the multi-cloud orchestration options that have been piloted with things like Terraform and done for some users on Jetstream, but making that a little wider, being able to have some push button virtual clusters where if you have your allocation and you want your own sort of virtual resource to be able to deploy that more easily, to be able to federate authentication for some of these other services, and even higher commitment to uptime than required, and just providing a lot of resources. We'll be using Rome for our storage nodes, but Milan for all of our CPU and GPU and large memory nodes. Little different processor, the 7702 instead of 7742. We'll also have a lot of A100s, and be able to subdivide those with the multi-instance GPU, and then hybrid storage as well. So both NVMe and disk, about 5 petabytes of NVMe and the rest disk-based. This is what it looks like at a broad level. We have regional partners with smaller systems as well, where we're targeting those for specific use cases, for discretionary use, to be able to say, how can we deploy some of these services centrally and spin up resources that are closer to instruments, to data, to other systems, to kind of pair with other resources, be able to hopefully expand those regional partners over time as well. And so that's something we're keenly interested in, and adapting some of the models from other other environments, like the Nectar folks in Australia have had a good example of how they've kind of deployed this amongst other institutions, and certainly an evolution of what we've done in Jetstream. If you look at the basic conceptual architecture, we have primary services, which are OpenStack based, that are interacting with these secondary services for providing container services, database, bare metal access if you need it, and orchestration. Kubernetes is all the rage. You can't not mention it these days, and maybe it'll continue. Maybe something else will evolve, and there's a layer there to be able to support, and then interfaces at the higher level for users to interact with. And I like to think of it from that user perspective of how am I interacting with Jetstream or Jetstream2. It may look differently depending on my use case. If you want to use a command line OpenStack Python tool client, you can do that. You can come in through Horizon and experience some of the scaling pains. You can use our own portal. You can use a third-party client that's been well tested and works on the API, or you can come in through a Science Gateway. And so users can see kind of a different system and different environment depending on how they come in. And interactive access is inherently a part of that. Being able to have virtual desktop sessions, things like that will continue to be important. So the timeline here, Jetstream is just about to start its 6th year of operations. Our goal is to provide some overlap between the systems, allow people to transfer allocations where appropriate. So I'd say if it's interesting, don't hesitate to get a Jetstream allocation and try it out and look to migrate that. We have dates that are subject to change. Like Carol, we're just kind of deploying things now, and only got our first storage equipment last week, quite a bit later than originally planned, and the CPU and GPU portions are still being built and assembled elsewhere. So if you are interested in being an early user, we will certainly pull from the Jetstream pool, and if people specifically have use cases, let us know. Our aim is also for production operations by October, and these will just depend on how the rest of the deployment schedule goes. There's certainly more to talk about in cloud interoperability commercially and other things that are options, but in our 10 minutes, I don't want to take more time. So our formal acknowledgments, thanks to the NSF, as well as some of the other Jetstream2 partners. So thanks to them, and I'll open it up for any questions.
Okay, great. Thank you, Dave. Seems like we could have a call on cloud interoperability on its own at some point. There's a lot of interest in that, I know. Somebody have any questions for Dave or Carol or Shawn?
I have a question for Dave. So you touched on this at the beginning of your talk, and it's about persistent usage where people want to use it for long term. This is something that I've seen quite a bit with our research as well, where they're looking to host data sets, or perhaps they're doing some sort of instrumentation that requires timed computation. So I'm curious. You said that it's still something that's being worked on. I assume that that's a big part of Jetstream2 as well. I guess what's the prognosis on that? Is that one that's really just that it has to be more of a XSEDE level? It's figuring this out because of how the projects are coming in, or is it more than that?
Well, I mean, I think it's one thing we can, people can look at changing perhaps in the post-XSEDE realm as well, but there's also been a push in XSEDE in these large scale community allocations, sort of 3-year type allocations, which get a review on an annual basis. You still have to submit your project report and things, but able to make a bigger commitment up front. So we definitely want to push that idea, especially for some of these larger projects. You look at the data sizes now, and all 3 of the systems are over 10 petabytes available. I know we have some individual projects that are like, well, I would like to move in a petabyte for this work, and it takes this much time to get it out of the commercial cloud or my data center, and I don't want to do that and then risk having to move it back in another year. So I think at that larger scale, we'll be able to be successful with some of these. I think for smaller projects, it may still be challenging, and it's more of just a desire to say, well, I have this grant or award that I want support for multiple years, and it depends on the NSF changing their tune, which they've not in the past. And I think with enough of us pushing for this as service providers, I think it's helpful.
Elisa has a question. Oh, did that answer your question, John? I don't want to move off your question if you're.
Yes, thanks, Dave.
Lisa said, a question for David. Can you talk about training plan for Jetstream2, especially training on how to set up running classes on Jetstream2?
Yeah, for sure. We did a little of this just trial by fire early on in Jetstream, where a 200-person course would appear days before it actually was conducted, and so we got to learn some hard lessons there, and those types of that scale of kind of support has been more routine. So we just encourage people to reach out to us if that's something interesting. There's also a lot of good examples. XSEDE ECSS folks have done lots of training and have some tools to do this within kind of a workflow. If it's something temporary for like a workshop, to say let's spin this all up based on these containers and use 100 nodes or more. We've had in some of these larger workshops where it's been like 400 people or so. If it's a course over time, there's certainly some best practices to say, well, this is how you want to have your students and instructors, teaching assistants, whatever, kind of get access and share things. So we'll definitely partner on any of that work as people have classes. There's no shortage of that, and there's a lot of good reuse in the community. So that's something I think we can work with you directly on, and there may be some lessons for virtual workshop type type training to say what are the training best practices or class best practices. So, 'cause we do have those, and it should be a little easier in Jetstream2 for some of the sharing aspects.
So where would they find that information, Dave? Just if they go to XSEDE and ECSS, the ones you're talking about that may already exist?
Yeah, so the things that already exist, we have a wiki at jetstream-cloud.org, and that wiki contains all our documentation with pointers to other projects like the Zero to Jupyter Hub type deployments where you want to take and deploy through Kubernetes Jupyter notebooks on something like Jetstream, and then use those in instruction or workshop. There's tutorials on and instructions on how to do some of those things, and there's other recommended kind of best practices. So as much as we can inherit from the Jetstream documentation, we will carry that forward, but there will be things that change, and we'll be sure to publish some of the same things.
Yeah, Lisa said too, it would be good, very useful for small graduate level classes on how to use certain software for research, which I think that you see people are using Jetstream and the High Supercomputer Center for just those things. So I suspect you all have these same need for this training information.
Yeah, and it can be good and bad, right? In a traditional HPC environment, it can be, well, just load this module. It's, what you want is already installed. That's great if what you want's there. If it's not there, and you're coming to Jetstream and there's not an image for you, it's like, well, build and install it yourself and support it yourself, which is great if you're dealing with Python modules and compatibilities with the core OS that create issues. But it can also be a challenge of, oh, this is my problem now, and it goes both ways.
And maybe that's something at the individual universities, that our research facilitators will help people get to Jetstream and set those up. Or, but I think it's a good discussion for another day too, how we can get these all at the.
Yeah, and there will be continued examples or images to say, oh, this biology focused image has everything I want that somebody else is supporting. I can probably just load that and use it, and so there's well over 300 community supported images on Jetstream, and so you expect to see kind of the same thing of the community supporting itself. Sometimes well, sometimes not, but that's where it is.
Well, we are at our time here at 1 o'clock. Went very fast, but like I said, and I think Rich and the members on the call probably would agree that we'd love to have you guys back for a little bit more in-depth conversations and maybe stepping through some things. I think Jetstream with all the different images that you have, it's just a wealth of information that these new emerging centers can help support their researchers with if they don't have their own tools. So that's kind of where we're at. Anybody else have any other questions? Or we will send out, if we can have you guys' either links to or the actual slide decks, we'll send them out in a follow-up email to the community. So I think that would be useful. And I think that's about it. Rich, do you have anything else, or Carol or Shawn or Dave, any last words, except for it's exciting stuff. But as I always say, there will never.
Again, thank you for the opportunity to share. We'll be happy to come back with more details, and I'll send the PDF to you.
Okay.
Ditto.
All right.
Thanks.
Okay. Well, thank you, everyone.
Thanks, everyone.
See you next month.
Thank you.